8.5 Regular annuities. Let's look at something called an annuity. So, what is an annuity? Well, everything up until now in this chapter, we've been dealing with making an investment or borrowing money, but only doing a one time principal payment. Now, in reality, people make regular payments. They make regular mortgage payments or payments on car loans, or they make regular payments to their investments or your bank account, your savings account. You don't make a one time thing and you forget about it. No, you make regular payments. So, when we deal with those regular payments, we call that an annuity. So, an annuity is an investment where a series of equal payments are made at regular intervals of time, and we use equal payments because it's just easier to calculate in this sense. Okay, an ordinary annuity is an annuity where payments are made at the end of each payment interval, and a simple annuity is an annuity in which payment intervals match the compound period. So there are different types of annuities. However, in this course, we're going to look at simple ordinary annuities. So this is where the payment interval matches the compound period. So if it's a compounded monthly, then your payment period is every month. And we're also looking at the same annuities where the payments are made at the end of each payment interval. Okay, so the formula, well, like here's a spreadsheet example. So suppose you want to start saving money by depositing $500 at the end of every year into an account that pays 6.5% compounded yearly for 5 years. So we're looking at the regular payments, yearly payments, because the compounding period is a yearly, and we do this for 5 years. So in the beginning, you have nothing, okay? But then you make a payment at the end of the compounding period. Remember, you're always making a payment at the end of the period. Payments are made at the end of each interval. So $500 at the end of the interval, $500 is our balance. The next year, we calculate interest, $32.50, and then we make another $500 payment. Our new balance is for this 500 plus the 3250 plus the 500 for a total of 1032.50. Then that becomes your balance for the next year. You calculate interest on that, and then you make another $500 payment, and then at the end of the year you'd have $1,599.61. And then at the end in the fourth year, you take that $1,599.61, you calculate some interest. That interest is going to be $103.97. This is all based on the compound interest future value formula. You'd get this answer if you use that formula. And your payment is $500. So rather, let me I'm going to see if I can, basically, I'll show you how I get this number. So if I took $1,599.61 and I multiplied it by 0.065 rather, 6.5%, 0.065, I would get 103.97. So that's where that number is coming from. So all these numbers that are calculated here are just 6.5% of whatever balance that you have. Okay, so the new balance after I add another $500 payment would be $2,203.58. And that becomes the balance for year number 5. And so 6.5% of that balance is equal to $143.23, plus another $500 payment at the end of the interval, gives me a total new balance of $2,846.81. Okay, so that's how we do annuities, right? So how much money did we deposit altogether? 510, so $2,500, so $2,500 worth of payments, plus all of our interest gives us $2,846.81. Okay, so some notes: the period is 1 year. The balance at the beginning of the year is 0, since you are depositing money at the end of the year, or at the end of the period, or at the end of the interval. The interest is calculated on the balance at the beginning of the period, and the new balance represents all of this, the entire sum of the old balance plus the interest plus your payment. Okay. Now, how do I calculate this without a table? Well, let me introduce to you a formula that we can use. The formula for the future value of an annuity is the sum of all the deposits and the accumulated interest and can be found using this formula. Okay, so A is our, so let's write down these different variables. What do they mean? So A is the accumulated interest or the future value, accumulated amount or the future value. So accumulated amount or future value. R, this is a new variable we haven't seen yet. This is the regular deposit or the regular payment amount. So this is the regular deposit / payment amount. I is my interest rate per compounding period. And N is the number of compounding periods or the number of deposits. Or number of payments. All right, so example number 1. Steve makes a monthly deposit of $300 into an account that pays 4% per annum. Per annum means per year. Interest compounded monthly. So how much money will be in the account after 5 years? So we're looking at the value for A. What is A? Okay, the regular payment is $300. So we're making $300 per month, monthly deposits. My interest rate is 4% per year. Okay, so 4% per year is 0.04, but because it's compounded monthly, I have to divide that by 12. Okay, and the number of compounded periods, well, over 5 years, we have making monthly payments of 5 times 12 is 60. Okay, so then you apply the formula. So the formula says A equals, let's write out the formula, R times square bracket, round bracket, 1 plus I, round bracket to the exponent n, minus 1, close the square bracket, divided by I. Okay, so what is I? When you do 0.04 divided by 12, that might help us out. That's going to be repeating decimal. So sometimes we just keep it as a fraction, but as a decimal, you write it like this. So 0.003, repeat the 3. Okay, but when I calculate it, just use the fraction. All right, so when I calculate A is equal to regular payments 300, square bracket, round bracket, 1 plus I is 0.04 over 12, close the round bracket to the power of 60, minus 1, close the square bracket, divide everything by my I value, 0.04 over 12. Okay, 0.04 over 12. There we go. Now, if you put this into the calculator, make sure you do this part first. 1 plus 0.04 over 12. You should get 1.003, repeating 3. Then take that number, raise it to the power of 60. Then whatever answer you get, subtract 1. And then you multiply that with your 300. Okay, and then you divide everything by 0.04 over 12. Make sure you use your brackets as well in your calculator. You don't want to make any mistakes. So practice this on your calculator. The answer that you should get for your final value of A is $19,889.69. So that's the future amount. So therefore, after 5 years, there will be $19,889 in the account. Not bad, right? For depositing $300 a month. So how much interest is that, right? Because that $19,000, most of that was your, most of that was your deposits, right? So how many deposits did you make? Well, if you had 60 deposits, okay, well, 60 deposits times $300 per deposit is, how much is that? $18,000. If I calculated that correctly, yeah, $18,000. So if the interest, if I want the interest is just the amount minus the total deposits, right? Total deposits. So if I have the final amount of $19,889.69 and I subtract those $18,000 I deposited, the $300 over every month, The money left over is the actual amount of interest I earned. So the interest is $1,889.69. So $1,889 of this $19,000, that's interest. Okay, almost $1,900 of interest, which is pretty good, right? Free money, just for investing. Okay, let's look at another example. Example number two. Kelly wants to retire in 25 years with $1 million in savings. Her investments are earning on average 12% per year compounded annually. What regular annual deposit must she make to have the required amount at retirement? So here's a little bit of a reversal here. I have the final amount. I want $1 million in retirement. What's the regular payment? Okay. The interest is 0.12 because it's 12%. Convert that to a decimal. Always convert it to a decimal, even in the annuities section here. And the number of years here is 25. So n is equal to 25. So this is a yearly period, compounded annually, every once a year. How much money do you have to put into the account every single year? Okay, so if I start with the formula, okay, let's write the formula out. A equals R. Stick there. Let's change that. R times square bracket 1 plus I to the power of n minus 1, close the square bracket divided by I. So what I'm looking for is R. So I have to rearrange the formula so I can get R. Okay. So let's plug in the values that we do know. So 1 million for my A value equals R times 1 plus I is 0.12, so 0.12. Round brackets, don't forget those. Raise to the exponent 25, n is 25, minus 1, close the square bracket, divided by I, 0.12. Okay, so, how do I rearrange this? Well, if I cross multiply, so you bring this guy up here, and you bring this square bracket down here, you would have your R isolated, right? So how would that look like? Here's how it would look like. So I have 1 million times 0.12, divide that by my square bracket, 1 plus 0.12 to the power of 25 minus 1. That's going to equal what I have left over there on the right side, R. So all I'm doing here is just cross multiplying. Okay, so the denominator goes up here, this square bracket goes down here when you divide it on the other side. So I'm going to divide. Okay, and then you get your R. All right, so that is this guy right there. And if I solve for R is going to be 7,499.97. Okay, and that is the example there. All right, some practice problems for you to try.